So the thing here is data set plays very important role. Yesterday, I already showed the path for data sets. Today, let me repeat those 3 to 4 different type of data sets where 3 to 4 different type of websites where you can find some data sets. The first, still many are yet to join. Oh, we just crossed 110. We have to cross at least 200 today. Let's wait for 1 or 2 more minutes. Let me remind them in the group. 1 second, Jai Shankar. Let me remind them in the group. Meanwhile, if anyone wish to share anything, you can raise your hand. I will unmute you. We have to cross 200. Maybe people are busy in their regular activities. Let me remind them in group. Some interns from Power Engineering College are there, though they are doing very good in on LLMs. One guy name, I think. 1 second, let me tell you one guy name. One guy, Pawan Kumar, is there. Ashmita, okay. Ashmita is there. Aditya also there. Another, yeah, Hari Pratap. Hari Pratap, did you join? Hari Pratap, if you join, just raise your hand. Manohar, not. Hari Pratap. Some interns and some people are really doing very good. Manohar only. Okay, let me remind them. Meanwhile, if anyone wish to share anything, just go to reactions, raise your hand. I will unmute you. You can ask questions. Yes, Manohar, unmuting you. You can ask your question, or if you wish to share anything, you can share.
Sir, the best tool for annotation?
Supervisely is there. Supervisely.com. You can try. It's a cloud one. It's a very good one. Otherwise, RoboFlow also provides that labeling feature. SageMaker is also giving that option, but I like Supervisely. It's really very good.
Supervisely. Okay, sir. Thank you.
Supervisely.com or supervise.ly.
Okay.
Yeah. Any others? If you have any questions, just go to reactions, raise your hand. Today we'll see classification from Priya Madam joined. So wait for a few more seconds. Meanwhile, if you wish to share anything, just go to reactions, raise your hand. Still 138. Okay, Hari Pratap just joined, it seems. Hari Pratap, I called you many times, yaar. Hari Pratap, go to reactions, raise your hand. Hari Pratap from batch 7. Power Engineering College, Tamil Nadu. I want to show this guy's outcome. Okay, Redmi Note 7 Pro. Okay, Mr. Hari Pratap, raise your hand, man. I called you many times. Unmute yourself. So yesterday said that will be apply video for predicting YOLO model. Okay, 274223. Just do one thing. I will share one link with you. In that we just coded how to inference with web camera. It's very simple. I'll share the code. After that, just message me. After the session, message me. I'll share you the code. Okay, Hariprasad just left. Again, he'll join, it seems. Network issue. Okay, coming back. So today we'll see another project. Haripriyanka madam, I'm making you as co-host. Please share your screen and over to
Good
you for a few
evening, sir.
minutes. Good evening, madam. Please introduce yourself and share your screen. And don't forget to disable annotation. People will start annotating on your screen. So after sharing your
Sure, sir.
screen,
Yes,
just go to
yes.
security and disable.
Yes, I'll do that. Thank you. Thank you so much for giving me a chance to present myself here. I'm Haripriyanka. I am a passionate teacher and I'm a researcher. I have finished my BTech, I finished my MTech, and I'm passing my PhD right now. I am passing my PhD in deep learning. I'm working on deep learning models. So today I'm going to talk about classification within few minutes. Again, thank you all and hope that this session will be fruitful. Thank you for joining me.
Haripriyanka madam, you're on mute. You're on mute, madam.
Yes, sir. Yes, sir. Yes, sir. Shall I wait for some time or shall I start?
Yeah, please start, madam. And disable.
Yes, I'm disabling. I'm disabling.
It's still there, madam. Just stop sharing your screen. Just go to security.
I did. 1 second.
After
I'm sharing it again. I'm sharing it again. Yeah.
We have 99% very good guys. 1% monkeys are there. So we have to disable.
No, they should be there. Yeah, it's already disabled. I did it. Yes, so good evening again, everyone. I'm going to talk about convolutional neural networks today. Right. So why do we use convolutional neural networks? Yesterday, sir has given some good examples. He has shown us what is YOLO, one of the network that is mostly used for object detection, right? So convolutional neural networks in general, in a broad way, you can say that they are used for three things in deep learning. They are used for image processing, right? In image processing, we have three things that we can learn. When we are saying deep learning or machine learning or artificial intelligence, the common thing here is learning. Who is learning? Are we learning something? Who is learning here? When we are talking about machine learning or deep learning, I would like people to, I appreciate if you are interacting with me throughout the session. So what is the time I have? 20 minutes or 30 minutes?
20 to 30 minutes, madam.
Right. Okay, sir. Okay, so please do tell me when I'm done. I mean, if I am crossing my time.
You are the only presenter today. So you have
Okay.
around 30 minutes time, not an issue.
Yes. Okay. Amina Praveen has answered. Machine is learning. Very good. Absolutely. So who is learning here? The machine is learning, right? So when we are talking about this learning, yes, machine or system is learning, we are making the machine learn. Or in short, we can say that we are making the machine to think like we are thinking or to perceive something like we are perceiving. Okay. So when you're talking about perceivance, or looking at something. Perceiving something is looking at something. So obviously we look at images. Whatever we look at, that is an image. Okay. So we are trying to teach a machine to look at an image like we look at that image, right? So if I have a table full of fruits, okay, and if I'm able to differentiate that this is an apple, this is an orange, this is a mango, this is a banana, then my machine also should be able to differentiate when it looks at these fruits. That is what we are trying to do, right? So what are we doing here? Because it is a machine, it will take an input and it will give you an output. So simple, we are telling that machine that we are giving the machine a different one image which contains different types of fruits, and we are asking it to tell which one is what. Okay, so if I'm asking it to tell where are apples, so then it will tell yes, there are apples. Or if I'll show one fruit and ask whether it is an apple, mango, or banana, then it will tell yes, this is an apple. Or it will tell that I am sure that this is 99% it is an apple. Some 1% it might be a strawberry, and 0% it is banana. Okay, so the machine answers in this way. I think this is what is called accuracy, what we have seen, which if you have already worked on some models, or if you have learned something, or if you've heard something about deep learning or machine learning, everything, the output itself, they speak in terms of accuracy. So this is what is called accuracy. So when I show one apple, one banana, and one mango, and if I ask the machine, do you think this is an apple? Then the machine will say, yes, I am 98% sure it is an apple. Or if you did not teach the machine properly, you did not learn properly, then it will say, I'm 50% sure this is apple. And it will see the strawberry and say that 50% I'm sure that this is also apple. Right? That is a difference between a machine that is trained properly and which is not trained properly. Correct. Identifying the object with confidence. Yeah, identifying the object with confidence. Okay, so you were trying to define what is accuracy, I think. Yes, Kalyani. Yes, thank you, thank you. Yes, it is identifying the object with confidence. And the percentage what I was talking about is the percentage of confidence that machine is having on that object. Correct, absolutely. So when we are talking about classification, so do convolutional neural networks do only classification? Yesterday, Sister was talking about object detection, right? So what do convolutional neural networks actually do? They do three things. One is image classification. That is what we are talking about today. Image detection. That is what Sir spoke about yesterday. And one more thing is image segmentation. Right? Image classification, detection, and segmentation. Yeah, so yesterday what Sir was talking about was detection. Okay, so if we have seen there was one lady and there was some background images, and even when the lady was moving, the camera is able to identify that there is a cup in her hand and there is a chair in the background, and there is a woman screen, there is a face. If the name of the lady is shared, then the name will be displayed, and so on, right? So that is image detection from the given. Yes, I'm coming to that, Shiva. I'm coming to that. So what is image segmentation? I'm coming to that. Yes, so image detection is given a screen or a set of images, you are able to detect this is this image, this is this image. Now you know what is image classification also. That also we discussed yesterday, saying that if this is a cat and this is a dog, or this is an apple, this is a mango, you have to classify. That machine has to classify that this is apple, this is mango. Segmentation. When you come to segmentation, we use convolutional neural networks to segment one part of the image, to segment one part. This is called instance segmentation. This is also called as instance segmentation. Instance segmentation. Okay. Now, what is instance segmentation? For example, I say that, as I told you yesterday, we have drawn some boundary Same applies to videos also. Correct. Same applies to videos also. Yesterday, as sir has shown, when you're detecting the object using YOLO model, you look only once. There are some boundaries that are detected around the objects, right? Now that is detection. When you're segmenting the image, instead of boundary, a clear contour means an outline of that particular image is highlighted, and different classes in the image are colored in different ways, right? So if you give me a minute, I will show you with an example. Yeah, please give me 1 minute.
Madam, your screenshot got screen is blank now. Just stop sharing your screen.
No, I made it blank, sir. 1 second. I
Okay.
want to share something else.
Okay.
Yes. So these are some of the examples of image segmentation or instance segmentation. Okay. So if you look at this, example, you can see that this is the classification and localization where you're just drawing a boundary. But in this image, where you have sheep, grass is in green color, sheep is in yellow color, and your road is in gray color, right? So you have given 3 inputs to your model, right? You have given 3 inputs to your model, and each input and the model is predicting. It is learning from the input training data, and it is predicting. Looking at the test data, it is saying that, okay, there are 3 different classes in this image, and each class, it is drawing one neat boundary line. Instead of just boxing it out, it is drawing one neat boundary line, and it is segmenting each class, right? That is called image segmentation or instance segmentation. This is also one of the applications of convolutional neural networks, right? Yes, you can see many examples. If you just say instance segmentation in Google, you can find many examples, right? Again, I'm just not I'm sharing my screen back with my okay. Right now, how this image segmentation is done. There are many models for that also. For everything, convolutional neural networks. These neural networks are used for images, mainly used for images, right? What is a basic working in just for 5 minutes? We'll discuss how a convolutional neural network works. What does a convolutional neural network actually contain? Can somebody tell me? What is a convolution? Could you please refer any materials to learn deep learning and AI? Definitely, Archana, I will refer. Yes. Yes, to predict object. Archana, I would suggest if you are able to watch some Coursera videos by one person called Andrew Ng. Andrew Ng. ANDREW-NG is his name. So there are many videos of his. So you can just watch some of his videos, some introductory videos to deep learning. They are very helpful, right? And there are some materials also I will suggest. To predict object. Yes, we use convolutional neural networks. Yes, sir.
Yeah, actually, we made very good video on CNN. What is CNN? How it works? How it works in the background? What is the mathematical equations? What kind of formulas they
Yes.
use? And
Yes, sir.
all these concepts we made a simple and very powerful video. If possible, we'll share to
Yeah.
a few people. Anyways, please stop comments for some time and continue with your content, madam. At last, we can take the questions from comments.
Yeah, that would be better.
Please continue.
Yes, correct. Yes. Okay, so as sir said, we'll see that video later. Then convolution neural network, as I said in brief, it contains a filter it contains a filter which convolves means which moves along an image. Okay, it contains a filter which moves along an image, and it will record or it will observe what are the features in the image which are dominant, right? What are the features in the image which are dominant? Okay, now for example, as I told you, if it is an apple, okay, if the image input image, the training image is an apple image, what are the dominant features in apple? Apple is round in shape, it has red color, more of red color, right? So some apples can be green also. Okay, so when you are training your uh, model, you are supposed to give all kinds of apples. Only then your image, your model, which is classifying your images, it will identify all kinds of images, right? So your convolution neural networks will have a filter. These filters will observe the image, they will convolve, means they'll move along the image, try to identify what are the different dominant features in the image, record those features or remember those features, and if these and they try to predict something out of those features. That is what is important, they try to predict something out of these features. After the prediction is made, this prediction is compared with the actual input that is given. You have given an actual apple input, so with the actual apple input, this prediction is compared. After the comparison is made, obviously because this is a machine and it does not really know what is an apple, there will be some amount of error. Okay, so when I'm talking about all this, everything is mathematics, everything is done in numbers. Okay, everything is done in numbers. So for example, if I got that 50% this is an apple and the actual image says that 100% this is an apple. So there is a error of 50%, right? There is an error of 50%. Now, what this model will do is it will back propagate, means it will go back uh, to the first layer, and then again it will try to execute all the weights. It will try to change the constants, gradients in between, and then it will come back and it will try to improve the weights. It will reset the weights in different hidden layers, and it will again check what is the predicted outcome and what is the actual outcome. Okay, so if this process happens for all the training images, what are all the training images? Those are the samples that you have given to your model. Those are the samples that you have given to your model. If this process happens with all the samples, what? The forward pass and the backward pass and the changing of weights, all this together becomes one epoch in your model. Okay, the forward propagation along with backward propagation, everything becomes one epoch in your model. Okay, so usually with one epoch we cannot achieve the accuracy, good accuracy. You cannot achieve good accuracy. What is accuracy? What is accuracy? Accuracy is, now for example, I have given 100 samples in my training data. I have given 100 samples in my training data. So by now you might have understood, and I think that you all are familiar with these terminologies, right? What is training data? What is testing data? What is validation? What is a sample? Sample is something which you give to your model to learn something. Okay. So if you give one sample, it will not understand. Yesterday, sir told that we have to give 1,000 images at least, right? So always your numbers must be in thousands. So one sample, you will not, the machine will not understand. You need to give thousands of samples. Okay. So for all the thousands of samples, one forward pass and one backward pass, and all the batches in these samples. Now, 1,000 images cannot be processed by your model in a single go. So what you have to do, you have to divide them into batches, right? Batches of multiples of 8. So it can be 8, it can be 16, it can be 32, it can be 256, etc. Right? So I'll show you all that. I'll show you in code in within few minutes. I'm just telling you. So based on these samples, some predicted outcome will come. This predicted outcome is compared with the actual outcome, input, and then the error is tried to reduce. Okay. Depending on the number of epochs, your error will be reduced. More number of epochs, less amount of error. Again, that is also a decision that the trainer has to make. The person who is actually training the model, the person has to take. Too many epochs will make your model overfitted. What is overfitting? What is overfitting? Can somebody please? Okay. What is overfitting? Overfitting and underfitting. Lots of data is feeded. Lots of data is feeded. Less variance and high bias. High variance and low bias is overfitting. More number of image, too many epochs. Yes, too many epochs can overfit your model. Usually you say that your model is overfitting when, see, for example, very simple example I'll give you. A real-time example. For example, that you have taken a train and you have gone to some new place. Okay, you have gone to a new place. You got down at the station. As soon as you got down at that station, somebody came and robbed you. Okay, they robbed you of your belongings or your some important valuables. Okay, so what you say is, see, when you are something like that happens, what happens? What instantly, what we say is, this place wherever I've gone, all robbers in that place. People only rob you. Okay, that is called overfitting, because just because one person has robbed you of your belongings in that station, that doesn't mean that the whole place is like full of robbers. Okay, means you are overfitting. Same way here also, if you are training your model with the same type of data, imagine that you have trained your model with 1000 apples, 200 bananas, and 800 mangoes. Now, what will your model predict all the images as? Most of the images will be predicted as, I have given 1000 apples, I have given 200 bananas, I have given some 500 mangoes. Yes, it will predict all images, all the fruits, whatever you have given, it will predict as apples. This is called overfitting. Okay. Or whatever image you give from your data, or the same kind of images, what you have given for training, the same kind of images if you are giving for testing also. I don't say that you are giving the same images, same kind of images, type of images for testing also. It will predict properly. This is apple, this is mango, this is banana. Okay. Now imagine that when you are training your model, you have given high resolution images, good images, high resolution images. Okay. But in real world, there is no guarantee that you will get all high resolution images. You know where we find all these problems? When we are working with medical images. Why I'm talking about all this is because when we are working with medical images, there is no guarantee that everywhere or every time you will get an image with the same resolution. Right? So that is why I'm talking about all these things. Okay. So when you are training your model with all high resolution images and your model is working perfectly fine, you have given 10 categories. Okay. You have given 10 categories and all 10 categories it is giving you output of 99% accuracy. Means it is perfectly identifying. Okay. But you have given one image which is of low resolution, not of the same quality which you have trained your images with. Then what will happen? Your model will not work properly. Right? Your model will not work properly. Okay. Yeah. So that is what I'm trying to explain, what is overfitting and what is underfitting. Okay, so let us just see. I'll just show you one example project that I've worked on. I think you are able to see my screen. Okay, yes. Yeah, so I have worked on one project which identifies, which is a classification project. And this I have done in Keras using the Keras framework, TensorFlow and Keras, right? So TensorFlow is one set of library, is a set of all functions and libraries which contains lot of algorithms on machine learning and deep learning. Keras has lot of inbuilt or already pre-trained models or applications. I'll show you that here. There is one, you can directly go to keras.io API applications. So here you can see all the models. Underfitting means unlabeled data. I'll take the questions in the end, please. Definitely, please write down the question somewhere. I'll take it in the end. All the questions. Okay, let me finish with my project. Right, so Keras applications, these are the Keras applications. You can see the different models which are used for classification here. Okay, so you can directly go to this Keras website and you can see that there is a big API given, a reference API, where you have all the applications. You can take up any of these models and you can test your data with any of these models. There is a very good classification, or you can say description given for these models. Okay, so there is accuracy given, top 1 and top 5 accuracies, parameters. This is most important, the number of parameters each model is taking. And what is the depth of the model? Depth of the model is the number of layers inside the model, right? So today I'm going to teach about a basic model, that is VGG16. I worked on VGG16, I worked on ResNet 50. ResNet 50 V2, that is what I worked on. Difference is, if you can see these numbers here beside the model, that is the number of layers inside your convolutional neural networks. So in your neural network, you have an input layer, you have an output layer. That is what we see actually. But there are many hidden layers inside, which actually perform the operation of CNN, or the operation of identifying the features. Okay, so the number of hidden layers is the depth in your network. So here you can see the depth in all the different neural networks that are given. Okay, so obviously the more number of depth, higher is the number of parameters. More is the number of depth, higher is the number of parameters. There is some time also given, which is called inference, per inference. Okay, this is in milliseconds, I suppose. So for each epoch or for each training, what is the number of the time taken? Okay, that is the time given here. Now, all these models, as I said, these are pre-trained models. Pre-trained models, just like YOLO. YOLO is a pre-trained model. VGG16 is a pre-trained model. RASNet is a pre-trained model. What is a pre-trained model? A pre-trained model is where there are already some images that have been taken. Those images are available in the ImageNet dataset. So in this ImageNet dataset, there are some 10,000 classification of images, means there are 10,000 categories of images and some millions of images. Using that dataset, on that dataset, these models were trained, right? And once a model is trained on a particular dataset, it will record all the features inside that dataset. Okay, because ImageNet is having all the features of images, many features of the images, all these models also have those features recorded. What we can do is we can use our own data set. I don't have to use ImageNet. I can use my own data set, use the features, only the weights which have been recorded by these models, and then train my data using those weights. Okay, I'm not training my model from scratch, but I am using the weights or the features already recorded by those models, VGG16, RESNet, and so on. And using those features, in my data, it is going to identify the features and then give me the output. Okay, that is what I am doing here in my project. Right. So yes, you can see the platform. It is very clear. I am using Google Pro, Google Cloud Colab. Sorry, yeah, Google Colab Pro. And yes, this is part of my research. The kind of images I have taken, sir was specifically saying that we need we have to use medical images. So the kind of images I have taken is are medical images. Let me just mount my images, mount my drive here. I hope you are familiar with using Google Pro and doing some training using Google Pro. Whatever images you want to use your data set, whatever your data set is, that data set must be in your drive, in your Google Drive, in the same account where you have your Google Colab, wherever you're using your Google Colab. Okay. Yeah, Pro, why I'm using Pro is because at one point I have used up all my memory. That is 13 GB, I think, which was given, free memory was given by Colab. Now Google Colab Pro is giving me 32 GB of memory. Okay, let us see if my drive is mounted. Yes, my drive is mounted. You can see here. Yes, in this Colab notebooks. Yeah, these are all my data sets, some of my data sets. So I have a lung CT COVID data set. I will tell you where I got the data set from. Lung X-ray data set. Now I am talking about lung CT COVID data set. Means CT is CT images. And yes, your data set has to be arranged like this in these folders. One is the testing folder, train folder, and validate folder. Now I'll show you my drive. Yes, in my drive, you can see that this is my Colab notebook. Inside this, yes, I'm working right now on lung CT images, CT scan images. In this, your data set has to be validated. It has to be divided into these three folders: train, test, and validate. Right? Yes. Inside training, what will be there? Inside training, in each of these folders, it should be given like this: your classes. Okay, your data must be labeled properly, right? So in my project, there are three labels. One is a pneumonia. PNG is the type of image. Pneumonia lung CT images, healthy images, and COVID lung images. Why did I take pneumonia and COVID is because they have many very similar features. There are many diseases in which, if you look at the CT image or the lung image, they are very similar in nature. They are clinically similar in nature. Okay, only an expert radiologist can tell whether this disease, for example, this is COVID or this is pneumonia. Okay, so our aim is to assist such kind of radiologists. Okay, in some other session, I will explain in much detail about that. So you can see these are the images, right? So there are some images which are rotated, if you can see. Okay, they are in the sideways. There are some images which are straight. There are some images which are sideways. There are some images which are rotated left side, right side, etc. Okay, that process of rotating the image in different forms is called augmentation, image augmentation. Why do we do that? Image augmentation is done when you have less number of images. Okay, if you have less number of images, this is one of the major problem that is faced in medical images, in finding medical image data sets. You don't get many images all the time. You have less number of image. When you have less number of image, what you can do is you can augment. There are many libraries. There are inbuilt functions in Python which will directly augment your data. Means they will rotate the image in many different angles so that the number of images in your training data set will increase. Right? So these are my images. Similarly, I have two other folders, test and validate. In both the folders also, your three labels must be very clear. You should not give different names. You should give the same name in 3 folders: testing, training, and validation, right? Okay, so in short, training is used for, these images are used to train your model. Validate is used for validating, means as soon as one epoch is over with all these images, in the same epoch, whatever they have trained, or whatever model has been, whatever images have been trained, they will be checked with these validate images. And as I told you, predicted and actual output. So this trained images, you'll get the predicted outcome. Once they validate, the model will check with the validation whether this prediction is correct or not. If it is not correct, then again in the next epoch, it will try to adjust the weights. Okay, I'm going back to my project again. So this is about my data set. Now the question is where I got my data set from, right? I'll show it to you. Yes, this button, okay. Yes, this is my source for my data set. IEEE data port. Sir gave one very important, shared one a very important point, saying that we need to have validated data, validated by radiologists, right? Otherwise, or you have to get the data directly from the hospital. When you directly go to the hospital, there is an ethics committee in the hospital. This ethics committee will decide whether they are going to give you the data or not. And they're going to ask you all kinds of questions. What are you going to do with that data? Are you going to upload it somewhere? Then if you're going to upload it, are you going to use our name, or will you tell the patient's name? All these things. So one way is that way, you can go like that, but it is a very big process. It will take a lot of time for us to go to the hospital and get the data, and the actual work will be left behind, right? So you can visit such sites where you get such validated data, which is validated by researchers, which is validated by radiologists, doctors, etc. Right? So this is one place you can see IEEE data port. You just have to log in, create an account in IEEE. If you log in, you can access all this data. So you see COVID-19 here. Yeah, because I'm working mostly on COVID-19 data sets. You have lots of data in this. You will have data about NLP. You will have data about image processing, everything. So somewhere out of this, I have taken my COVID-19 data set. And there is one more site which I want to share with you. That is, I showed you one more. Yes, you have seen lung X-ray, right? Yes, this is one more data. Here in COVID-19 data set, I got around 3,000 images. In this lung X-ray, I got around 13,000 images, 13 to 15,000 images. This I got from Grand Challenge. Satish sir. Yeah, I wanted to share this with you. You must, there is one platform called grandchallenge.org where we can take up a challenge. This is purely based on medical data set.
Yesterday I have discussed about this one. Grand Challenge and dataset search engine.
Yes, correct.
I showed this.
Yes. So one of the COVID pneumonia and all, that was one challenge that I have accepted in this. So if I sign in, I think I can show you.
Madam, proceed with your code, madam. Yesterday I have already demonstrated this one.
Okay, right. Okay, so this is about the data. Fine. Next, these are all the libraries that we require to classify our images. Okay. So TensorFlow, Keras, everything. This is the important library that is required, image data generator. So in this, using this image data generator, what we do is we convert our images into NumPy arrays. Okay. And then this is one more, we are using a sequential model. VGG16 is a sequential model, and I'm using a sequential model here also to add the extra layers that are required. That is the outer layers. Okay, what we are talking about 16 are the hidden layers. Finally, you need a dense layer and an output layer. To define those, we use this sequential model. Okay. Okay. Now here, the default dimensions of your image in my data set, all my images are of this dimension, that is 256 pixels height and width, right? So you can take any of the dimensions. Then we have the weights, where we are going to store the weights of my model. Okay, fine. Then we have the paths that we are giving, where I have stored my train, validate, and test data sets. Okay. Then the number of epochs and batch size. This batch size is important. As I told you, all the images. Now, for example, in my training data set, if I have 1,000 images, all 1,000 images cannot be processed at a time. They have to be divided into batches. So my batch size is 256. It can be 64. I have taken the highest batch size here. Yes. So here at this point, I am downloading the VGG16 weights. As I told you, there are some recorded weights that are already there in your Keras applications. Those models are trained using different types of images. We are only taking the weights of those models, and using those weights, we are trying to train our new data set. Okay, train the model using our data set. Right. So here, all we have to do is include this line. VGG16 is the model name. Applications.vgg16 will get all the weights from there. Right. Include top layers. No, it is false. As I told you, I will include the top layers because VGG16 had, when it was trained, it has 10,000 classes. In my data set, I have only 3 classes: COVID images, healthy images, and pneumonia images. Okay, so I will include the top layers, means what is the input layer and output layer. Those are the top layers. Hidden layers are the 16 layers. ImageNet weights are used. So I am telling that. And what is the shape of my input image? Shape is height, width, and 3. 3 is the channels, number of channels in my image. Usually, if it is a grayscale image, you have 2 channels. One is 0 and one is another one is 1, black and white. But mine is an RGB image. Okay, so you can say that, ma'am, when we saw your COVID image, it is in black and white. It is not RGB. No, it is an RGB image. If I take a gray and what do you say, black and white image, the gray matter in your medical image will reduce. The amount of gray matter in your medical image will be reduced to complete either black or white. Okay, so we don't want that to happen. So what we do is we keep that gray matter as it is from the DICOM image, and we take it as an RGB image. Now, because we have 3 channels in my image, red, green, and blue, every image will have 3 channels. We are giving the channels as 3. Right. Next, I am just creating one data gen here. This is rescaling my image to any value between 0 to 255. Okay, we are just, what do you say? We are rounding the values. There can be many, your grayscale can range up to 2000. It has around 2000 values, your grayscale. That is your gray type of gray color will have around 2000. So we are just rounding it to 255. Okay. Right, so we are down here. I have already run this previously. That's why it is showing that, yeah, it is downloading all the weights from my application. Applications is not defined because I did not run this before. Okay, what is not happening here? Right. Yes. So the flops data was missing. Flops is floating point operations. If you want to know how many operations your model has done, then you can use flops. Yes, we are importing the weights so that we can use it. Yes. Right. This is the model summary. So these are all the weights. This is the input layer. 256, 256.3 that I'm giving as input. These are all the hidden layers. You can see that the number of filters, 256 is the height and width of my this thing. Now in between I'm processing and I'm giving the number of filters. Okay, so I'm using a convolution neural network with 64 filters, right? So initially we are using 64 filters. Then after that, you can see the dimensions have reduced. I'm using 128 filters here and so on. I'll maybe another session I can take what is a filter and how that happens. After that, what we do is here we are converting our data, our images into NumPy arrays. Why are we converting into NumPy arrays is because I don't want to work on images. Instead, I will work on numbers. Okay. So instead of working on an image array, it is easy to work on a number array. The work will be faster. Training will be faster. That's why we are converting your images into NumPy arrays here. Okay. So you can see that datagen.flow from directory is the function that we are using, and we are taking the images from the training data directory with the image width and height, which is already given, and batch size. So when we are converting into NumPy also, we are doing it in batches. We are storing them in some samples. And the number of classes, how many classes we had? We had 3 classes in my training data set: COVID, pneumonia, and healthy images. Okay. Then we are also creating one training variable in which I am just storing the number of samples that I'm going to train. Okay, so this whole part will just convert your training images into NumPy arrays. NumPy arrays are number arrays. Okay, similarly, you have for testing and validating also. So you can see some output is given here. There are 2,400 images that are found belonging to 3 classes, right? So 150 images belonging to 3 classes, 320 images belonging to 3 classes. So in 3, this was training, highest number is training. These 2 are validation and testing, right? Okay. So same thing. Again. Yes, now my model, I am building the remaining part of my model. This is till here what I have done is, I have given what is the input, and I have converted my data into arrays, NumPy arrays, right? So finally these functions have identified that, see, datagen.flow from directory. This is the function. This is part of image generator class in Python. Okay, it is part of image generator class in Python. Right, so this image generator class is used to, it is an input stream. It will create one pipeline between your data set and your model. Okay, so that pipeline is created now till here. Then after that, your date and time, yes, I am using the sequential model, and I am flattening the data. Once all the data is finished, that is once you have trained the model, you can see the number of parameters here. Okay, these are the number of parameters that are generated. Now what I have to do is I have to flatten it. Flatten it means from this number I have to bring it down to 3 classes, just 3 classes. Okay, so we use a flatten layer which will just convert, or which will just reduce the size of the array, the NumPy array. Okay, and then we'll use the flatten layers here. I am using an activation function which is called leaky ReLU activation function. This activation function will activation function is, it will tell when a neuron has to be fired and when it should not be fired. Okay, so if it finds a matching feature, the neuron will give an output. If it does not find a matching feature, it will not give an output. Okay, so there are many activation functions. Leaky ReLU is one of the activation function which I'm using here, right? So like that, there are 2 dense layers that I'm using, which will completely take my image, and then I am using the softmax activation. At this point, please listen. when I'm using this softmax activation at this point, I am giving number of classes and I'm giving softmax layer. Now this function, what it does is it will take all the features, the numpy arrays, and these outputs will be finally again brought back to 3 different outcomes. Okay, one outcome is COVID, one is pneumonia, one is healthy images, right? So if it is a binary output, you have only 0 and 1. Now mine is not a binary output. Mine is a categorical model. Okay, at a categorical means you have more than 2. So mine, the output will be in 3 ways. Either it is 0, it is 1, or 2. Okay, so yeah. Finally, I'm just printing the model summary, and then model.compile. Loss is categorical cross entropy. See here, because I'm using a categorical output, we are using the loss as categorical cross entropy. Otherwise, we can use some other losses. Optimizer is Adam optimizer. And then metrics. What are the metrics that I want the model to show me? So I'm using accuracy and precision and recall, right? So we have seen what is accuracy, precision and recall we'll discuss. And number of epochs is 60. Here I will not give 60 epochs. I'll just give 5 epochs because we'll see if we are able to. Okay, no, that will take a lot of time. So, okay. Fine, we give the number of epochs, we give the batch size and validation data. Where is the validation data available and what are the validation labels? Finally, we are saving the weights of this model, right? And then evaluation. Once you have done with the training, then the next part is evaluating. Okay, just by training the model, nothing will happen. You have to evaluate it. Only when you evaluate your model, you will know how much your model is able to actually predict anything. Okay, so that is what this line says. You are evaluating your model.evaluate. So the most important steps here are, one is model.compile. Next one is model.evaluate. Right? Fine. Yes, so the output looks like this. This is the model summary of my, yeah, see you have 1 flattened layer, 3 dense layers. Finally, in the last dense layer, I'm converting all this amount of data to 3 classes, the output 3 classes. Okay. 60 epochs. You can see that the loss has decreased gradually very much by the end, and the accuracy almost reached 100. So they say that your accuracy cannot be 100 because if it is 100, that means your model is overfitting. So we can consider this model to be overfitting, but yes, it did predict very well. Yeah, so 76.56 accuracy I got finally after validating, not in training, after validating, I got 76.56. And after evaluating, this is the loss that is encountered, precision and recall. Yes, evaluating it with the test data. Test data is something which was never seen by the
Madam, your voice is not
graphed it.
Madam, your voice is not audible. Shajita, is it the same issue at your end also?
Yes, sir. I couldn't hear anything.
Yeah, madam, there is some issue. Okay. Might be some network issue at madam end. So guys, this is an overview of CNN, almost that project also finished. So I recommend you to start working on some medical projects. There are n number of data sets are available. Grand challenge, just use that particular website. Start working on those models, okay, those data sets, and start building model and make some UI also. August 15th is a contest last date. You have to submit before August 10th. You have to submit CNN model before August 10th. We'll announce the results on August 15th. Okay. So if you have any questions, just go to reactions, raise your hand. I will unmute you. You can ask questions. Then we'll wind up today's topic. Yes, Haripriyanka madam, you're back. Making us co-host.
Yes, sir. I lost connection.
Yes, some issue. So participants, any questions from your end?
Yes, I'm ready to take up the questions. So
You can disable screen annotation.
yes, sir. Yeah, so just briefly, I'll just show this is the one image that I have given for testing. So this image was a COVID image. You can see here in the folder name, it is a COVID image. So my model has predicted it as 99.91% as COVID. Healthy, it is 0.0, and pneumonia 0.09% as pneumonia. Okay, so whatever images I have given them, this is a healthy image. So it has predicted it as healthy. And one more image probably I have given as pneumonia somewhere. Yeah, so this is one way of training your model using your Keras applications in that VGG16. So instead of VGG16, you can use any of those applications that are there in Keras.io and use those weights on your own data set to train your model. So if given a chance, am I audible, sir? Hello?
You're audible, madam.
Yeah, if given a chance, I can explain how to build a model from scratch also, but that is some other day. I'm ready to take up questions if anybody has anything to ask. Two participants have raised their hands.
Veda and Jayakar, unmuting you. Please ask your questions.
Good evening, ma'am. It's a wonderful session.
Thank you, Veda.
Lots of insights from your end, madam. And one more, like one doubt where I stuck is that, like, if we are working on an ultrasound image, like the data sets related to thyroid cancer detection was very few, even in the source which you have mentioned also, very few, like it's in hundreds. So like if we want to perform segmentation on ultrasound images, like could you give me some suggestion like how to extract based on ultrasound features? See, most of the content is from MRI and CT scan, but a kind of suggestion like how to perform segmentation detection on ultrasound image.
Ma'am, one thing is ultrasound images you can take. If you want to perform segmentation, you need to have masks, ma'am.
Okay.
Segmentation mask. Now I have shown some segmented images, right? In instant segmented images. In that, actually what we do is, for example, if you remember the image where we have a sheep, road and grass, right? So what we do is first we create masks and we say that green color mask is for grass, yellow color mask is for sheep, and gray color mask is for road. We do it actually.
Okay,
that is called image masking.
Okay.
After you do that masking on your ultrasound image, you have to mask the image where the problem is.
Okay.
where the disease is present. Those
Okay.
masked images must be sent for training the model.
Okay.
And the output of the model will be its own mask. It will create its own mask looking at these whatever training masks you have given.
Hmm.
It is going to create its own image segmentation mask and give it to you if you are giving a new image which is not seen by the model before.
Okay.
So that is how we have to do it. For that, we have a application called 3D Slicer, ma'am.
Okay.
In that, you can create masks.
Okay.
There is
Thank
a
you.
lot of information available about 3D Slicer directly. You can go to YouTube and check some videos. It is an open source software. You can download and do a lot of experimentation on it.
Okay. Thank you, ma'am. Thank you so much.
Thank you, ma'am. No problem. Yes.
Good evening, madam.
Please unmute yourself.
Good evening, madam.
Good evening, sir.
Excellent explanation as well
Thank
as
you.
yeah. Madam, my question is, like, each epoch has an iteration. We go through circles or cycles.
Yeah.
Changing the weights till we achieve 100% or say nearby
Yes.
right predictions.
Yes, sir. Yes.
So in that case,
Huh.
you are talking about deep learning as well as back propagation,
Yes, sir.
which calls for huge computational infrastructure.
Which calls for huge computational?
Infrastructure, that is,
Yes, sir. Definitely
lot
it
of
does.
CPU or GPUs power
Definitely.
as well as
Definitely.
storage.
Yes, sir. Yes, sir.
So how to overcome this
Hmm.
and reduce the infrastructural costs, thus for an establishment or a computational center to bring down the total cost of ownership?
Sir, there are many cloud platforms that are available right now. Instead
Okay.
of GPUs, people are moving forward to TPUs, tensor processing units.
Okay.
The kind of computation that is done on a GPU, if it takes around 1 hour, in TPU, it will be finished in minutes.
Okay.
We can, in Google Colab, we have the freely we can use a TPU, sir. Only
Okay.
thing is you just have to do some kind of coding for that. Some
Okay.
part of code we have to add. That's it.
Okay.
So that then we can work on it. But as you said, in an organizational point of view,
Correct.
yeah, there what we have to do is the research is still going on, sir. This is a big, actually it is a research problem.
Yes,
It
yes,
is an
of course. That is the
open-ended
reason I
problem.
posed you that.
Yes, it
That's
is an
the reason.
open-ended problem. No, I said that I was talking about floating point operations, right? Flops.
Yeah,
So
yeah.
every model, every model, whoever is creating a model, they are working on reducing these flops.
Correct.
So it is like you have to juggle with the hyperparameters, the number of epochs, the number of layers, the number of connections, the type of models we are using. With all these things, we have to do some kind of juggling and we have to come out with a model
Trial and error
which
method
will
only.
reduce. Yes, 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 sir. As of now,
Trial and
that
error
is the
method.
only way. Yes, that as of now, that is the only way.
So if a mathematical solution is provided,
That would
it
be excellent, sir.
streamlines. It streamlines as well as it will give you a predictive
Yes.
time of computational result outcome.
Yes, sir.
See, you are
Yes.
saying hours in
Yes.
GPUs and minutes in TPUs.
Yes, sir.
Correct?
Yes, sir.
So bridging the gap would be a mathematical algorithm which really substantiates as well as brings down the cycle time of operation.
Correct, sir. Correct.
So, okay, we can collaborate on that. Then
Yeah,
on the
sure, sir.
end-to-end from scratch, you said. So I request Sai Satish Garu to organize one more session for Haripriyanka Professor Madam, so that we can have an end-to-end discussion for the larger interest of the students and the faculty. When we can have that?
We can plan, sir.
Yeah.
In August, we
So-
can plan, sir.
August. Okay, good. So, Madam,
Sure, sir.
this like this August 10th results submission is applicable to everybody who is attending, right? So, sir, Satish sir.
Sir, I'll share for Amos, sir. Amos Society is open. We'll share in the Amos group. How
Okay,
have you
good.
got this link? Our this group link.
Yeah. So,
Yeah, we'll share
Uh,
for all the Amos members, sir.
right. So, and the problem statement as well as the roadway or the path to every step of developmental success, man.
Yes, sir. As much as possible.
And-
Yes, sir, definitely. Whatever knowledge I have worked on, I will share everything.
Yeah, so that it can be a hand-holding session for the students who are taking up, as well as people like us to really work on a given issue. And
Correct.
definitely real-life application now that COVID is passed off.
Yes.
There are many in the pipeline now. Russia is coming up with Egyptian as well as African problem, which is
Yes.
undiagnosed disease. So about 50 people are isolated after landing. So this is
Oh.
recent news yesterday. So
Oh.
undiagnosed disease, they are yet to
Correct.
diagnose. So
Correct.
now, yeah. So now you have known sets, COVID, pneumonia, and healthy. Maybe you have to have images storage or images collection for this
Yes.
unknown disease also, which can immediately help the international travelers as well as countries who are facing this issue, madam, like Russia and the northern African countries.
Correct, sir. Correct.
So this kind of thing
We can
may
work
get a-
towards that. Yes, definitely.
I have links in United Nations sustainability as well as World Health Organization.
Great, sir.
Collaboration can be extended to that. We can get a grant also, so that you can have now trying this collab or in a laptop. We can have a systems in. We can have infrastructure in place to work upon, and you
Yes,
can rope in or you can draft in interns as final year students or whoever it may be, or from the industry, so that it becomes a group working on deep learning as well as machine learning as a predictive analytics with AI and ML as a backbone. Ma'am.
Yes, sir.
Yeah, we can work on it. And thank you for your time taken out of your busy schedule to enlighten all of us.
Thank you
really
very much, sir.
explanation was too simple as well as very understanding.
Yes, sir. Thank you, sir. Thank you.
Thank you.
I'm
once again.
always ready to share my knowledge and also gain knowledge from a lot of people like you.
No, I'm not that big, madam. Thanks are
No.
due to Sai Satish Garu. And
Yes, sir,
definitely
absolutely.
we can collaborate. Yes, sir.
Sir, thank you very much. Participants, if you wish to ask question, please go to reactions, raise your hand. We'll unmute you. You can ask questions. If anyone wish to ask questions, just go to reactions, raise your hand. I think no doubts, madam.
Yes,
Hari Priyanka, madam, thank you. Thank you very
Yes,
much
sir.
for joining the session. Let's plan more session in coming days, madam. Thank you very much,
Definitely.
madam.
Thank you, sir. Thank
Okay,
you.
thank you, participants, for joining today's session. See you all. Bye-bye.
See you all. Bye.